Alright, in this video we're going to be going over using distance formula and the Pythagorean theorem in some coordinate geometry proofs. So reminding ourselves, the distance formula and the Pythagorean theorem help us get some side lengths on the coordinate grid, and side lengths are going to help us figure out whether or not sides are congruent. So this is going to help us in our coordinate proofs, because when we're proving different quadrilaterals, proving the congruence of sides was part of that classification checklist that we've been working with. So just remember that if two segments have the same length, then they are considered to be congruent. So your quadrilateral classification checklist, again, is popping up all of the time. So everything that I've written in red, or highlighted in red, are places where you can use the slope formula to attack those portions of the checklist. So you want to take a highlighter or a colored pen right now, and pause this video and just get everything highlighted and marked up just like we have in this video. So all of the parts of the checklist that are in red, again, you can use slope formula for that. And then everything we've highlighted in blue is what we're going to be using the distance formula and the Pythagorean theorem for. So again, pause the video, make sure you have this marked and labeled very nice and clearly so that you can refer to it when you guys are doing your proofs. Now, this is your coordinate proof guide. So for this lesson, we're going to strictly be focusing on distance formula and the Pythagorean theorem. And you can see that you can use this formula or these formulas to prove each shape. Like you can use distance formula for the entirety even of proving a square, right? You can also use all of distance formula to prove that we have a square. And you can also sometimes use a combination of these things. So it's our job to just show you all of your options, and then you guys can pick what you are comfortable with doing when it comes to a test or a quiz or your Regents exam. So just tips and tricks. Major things I want to go over is make sure you are plotting your points. That should be step 0. Before you even start doing any math work, you got to plot so that you have a visual representation of what's going on. And then just make sure that after you have all of you want to make sure your work is very neat. There should be titles written for each portion of your work. It should be very, very clear what you are doing. No matter where I decide to look on your paper, I should see exactly what's going on. And last but not least, you want to make sure that you have a very strong concluding statement that goes down the family tree in proving whatever quadrilateral you need to prove. So if your concluding statement is weak and not detailed, you're going to lose credit. So you want to make sure that that's something you're really putting some attention towards. So we're just going to get right into an example. So we have the points D, E, F, and G form quadrilateral D, E, F, G, and we are going to prove that it is a square. So in my mind, how I like to envision this, I like to think about my checklist, and without the math, I like to think about the conditions that would actually help me prove a square. So I know I'm only using the parts of the checklist in blue right now, because we want to use distance formula and Pythagorean theorem. But in reality, you can use any of them. But for this case, we know parallelogram has to come first. So I first need to show that both pairs of opposite sides are congruent using the distance formula or the Pythagorean theorem. And then after that, for a square, I know that I need to be able to check off one thing from rectangle and one thing from rhombus in order to have that those square properties satisfied. So for rectangle, we're going to be attacking the fact that the diagonals are congruent, and in that case, we're going to have to find the distances of the diagonals, or the lengths of the diagonals, and then we're also going to go ahead and try to check off the fact that all sides are congruent, which again, we should already have all of that. If we already have the distance of all 4 sides, we're going to kind of be able to attack this right away. So again, for square, we need to be able to check off one thing from rectangle and one thing from rhombus. So let's get right into it. So first thing we want to do is plot our points. So we have D is 0, 5. We have E is negative 5, 7. We have F is negative 7, 2. And then we have G is negative 2, 0. Okay. So first things first, we're going to try to prove that it's a parallelogram by showing that both pairs of opposite sides are congruent. So we need the distance or the length of all 4 sides. So the first thing that I'm going to do is I'm going to pick a side to start with. I'm starting with FE. So the same way that we recommended you guys do slope, the organization aspect and the process is going to be the same for distance formula. So you got to write your points out. So point F is negative 7, 2. Point E is negative 5, 7. I don't know why it's writing like that, but okay. And the reason why you want to write these points out is so that you can label x1, y1 and x2, y2, right? Because that's going to help you when you substitute into your distance formula. You're going to be able to kind of clearly see what your points should be. So remember, distance formula is not something that's given to you on your reference sheet. So you got to just remember it. x2 minus x1 squared plus y2 minus y1 squared. And all of that is under the radical. So let's go ahead and make our substitution. So d equals radical x2 is 7 minus our x1 value. I'm sorry, I messed up there. Our x2 value is negative 5 minus our x1 value, which is negative 7. All of that is going to be squared, and then we have plus our y2, which is 7, minus our y1, which is 2, and that's going to be squared. Now notice I'm going very slow, and I'm not skipping any steps because we have those double negatives that pop up sometimes, and we need to make sure we're like on the lookout for that. So here I see we have negative 5 minus negative 7. So what's standing out to me right now is this double negative here, and that's actually going to turn into addition. So I'm going to rewrite this portion as negative 5 plus 7 squared. And I'm just going to rewrite the other parentheses the same. And then I'm going to go ahead and simplify. So here, my first set of parentheses, negative 5 plus 7 is going to be 2, positive 2 squared. And then we have plus 7 minus 2 is going to be 5. We got to square that. And this can be very tedious. It could be a lot of lines of work, but it's very neat. I'm very neat with my work, and you guys should be too. So we have 4 plus 25, and then we have that the distance of FE, or the length of FE, is radical 29. So for this case, you don't have to get your answer in simplest radical form because you don't need it. Like if you find another distance as radical 29, you know that those are equal. You don't need to necessarily get it into simplest radical form. So distance formula looks like that. You got a lot of lines of work, making sure we don't mess up with those double negatives. But I'm also going to show you guys how to use the Pythagorean theorem as well. Now, you should not switch up the method that you use at all, but I'm just going to switch up just so that you guys can see both. But you want to pick one method and you want to stick to it. So here, let's do the length of GD here. So let's do GD. Now, if we do GD again, we still, or you don't even really have to write your points out. I'm going to write the points out just to be consistent. We have negative 2, 0, and then we have D as 0, 5. But for Pythagorean theorem now, it's a little bit different. So GD is right here. So what you're going to actually do is create a little right triangle on your grid. Now, when you do that, you're going to be able to count the boxes to find the lengths of the two legs. So the length of this leg right here is 2, and the length of this leg right here, 1, 2, 3, 4, 5, is 5. So now when we're doing Pythagorean theorem, we're going to be able to find the length of that hypotenuse side here. And let's see if we actually get the same value, right? Because if we're proving that it's a square, it must be a parallelogram, which means that your opposite side should be congruent. So let's test that out. So remember, our A and B values are the legs. It doesn't really matter what we plug in there, either 5 or 2. So we get 5 squared plus 2 squared, and that's going to equal C squared. Remember, your C value is always going to be that hypotenuse. So your C value in this case is always going to be a side of the shape that you have. So we have 25 plus 4 equals C squared. And then if we do that, we'll get 29 equals C squared. And then we have to take the square root of both sides to get C by itself. So we get radical 29 equals C. Now, when we do the Pythagorean theorem, you might notice that it's a little bit less tedious to do this. You got to mark up your coordinate grid a little bit more, but it's a little less tedious, and you end up getting the same answer there. So what I would do, though, is not leave it as C. I would just be precise and say, hey, GD is equal to radical 29. And then even over here, it would be good measure to say, hey, FE equals radical 29. So what I like to do when I do my proofs is as I get findings, I like to write them in. So I'm going to draw arrows, and I'm going to say, hey, FE is congruent to GD. Right? And I'm going to go ahead and label that. Even though we have the numbers, I'm going to label that with my geometric markings as well. We're not done yet, though. We need to still find the distances of the other two sides. So now I'm going to do ED. And I'm going to go ahead and use Pythagorean theorem. It's a little bit faster. Distance formula just is a lot of work, and it's a lot of substituting, and there's a lot of room for mistakes. So for ED, I'm going to go ahead and make our right triangle here. You need to be very careful with this, though. It's easy for people to miscount the boxes, so go really slow when you're finding your lengths. So for ED, 1, 2, 3, 4, 5 here. Let's double check. Yep. And then we have 2 here. And then we're going to find the length of that hypotenuse. Now, what I noticed before I even write this in, like if I do a squared plus b squared equals c squared, I notice that I'm substituting the same exact lengths in. I have 5 squared plus 2 squared equals c squared, and that's the same exact equation as the one we did right here. So I'm not even going to do any more math. Like I'm not going to rewrite all of the substitutions. I just know that this is equal to radical 29 because we already did it for GD. So I'm going to go ahead and write that in here too. So radical 29. And now we have one other side left to do. We have side FG. And again, I'm going to do Pythagorean theorem. I'm using a different color here. Let's try to do this greenish color, I guess. I hope it shows up. So again, we want to make a right triangle and be very mindful. Oh, messed up a little bit. Be very mindful of you counting your boxes. You don't even have to draw dashed lines. You can draw fully solid lines if you wanted to so that you don't mess up counting. So here we get 2, and then we get 1, 2, 3, 4, 5. You get 5 again. So when we do a squared plus b squared equals c squared, when we make those substitutions, we're going to get again 5 squared plus 2 squared equals c squared. And I'm not going to go ahead and do all that math because we already did it, and get that radical 29 is equal to c. So again, I'm putting this in here, and what I see here is that actually all 4 sides are congruent. So you can even go ahead and say that, like, I would even put my arrows in here. FE is congruent to GD is congruent to ED is congruent to FG. And you can write it, you don't even have to write it like this because it can be a little confusing, but basically what I'm saying there is that all 4 sides are congruent. I'm kind of like saying to my grader, look, these are my distances, and look at what I found from my distances, right? Now we're not quite done yet. If you go back to your checklist, if you flip back to the page, I'm not going to change the slide because it would erase everything we have. But if you go back, right now we have something from parallelogram checked off, right? So I know, and I'm even, you know what? I'm going to start writing my concluding statement. When you get findings, it's a good habit to do that. So I'm going to just start writing what we found. So we know that DEFG is a parallelogram because and I'm taking my wording straight from the checklist, because both pairs of opposite sides are congruent. And now we also know something else. If you take a look at the checklist says if you have a parallelogram with all sides congruent, that's a rhombus. So I'm going to say DEFG is a rhombus since all sides are congruent. And now we need to check off something from rectangle. So again, the only thing from rectangle that we can check off with this method right now is the diagonals being congruent to one another. So we need to actually do the distance formula or the Pythagorean theorem 2 more times, and we need to do it for the diagonal. So we need to do it for diagonal, and I'm going to mark this, diagonal EG, in my title. And then we'll need to do it for diagonal FD as well. So your picture might be getting a little sloppy at this point. That is okay. I'm going to try to find a different color here if I have one. Let's use this burgundy-ish color. So diagonal EG is right here. Now again, this is a little bit trickier though. If you have a diagonal, your right triangle is kind of already created for you. You can create a new one though. But your diagram gets a little bit messy, so it could be tough here. So if the diagram is too sloppy to follow, use the distance formula. But let's change this color to yellow maybe, so we can visibly see what's happening here. So here's diagonal EG, and I'm going to make my right triangle right here. Boom and boom. Now the reason there's already a triangle that's created for us, but I'm not using those because one, I don't know that it's a right triangle, guaranteed, so I don't know that I can use Pythagorean theorem, so we just make our own. So here's the right triangle. Now when you're counting your boxes, we have 1, 2, 3, 4, 5, 6, 7 here, and be very careful counting. So we have 7, and then we have 1, 2, 3. So now when we're doing, I'm going to do this in a darker yellow. So a squared plus b squared equals c squared. We're going to get 7 squared plus 3 squared equals c squared. And then I'm running out of room here. We're going to get 49 plus 9 equals c squared. And then when we simplify, that's going to give us radical 58 is equal to c. So that's the length of diagonal EG. And then we're going to need the length of diagonal FD as well. So we need diagonal FD. And it's going to be the same thing. I'm running out of colors though. Let's use this color red, I guess. So for diagonal FD, or maybe I could do it a little thicker. For diagonal FD right here, we can create a right triangle by going like this and like this. And again, if this picture is too complex and you can't follow it, just do the distance formula with points F and D, just like we did up here. All right. So we have 1, and be very careful now. It's getting a little hard to count, but just go really slow. 1, 2, 3, 4, 5, 6, 7, I believe. Yeah, 7. So I'm going to write my distance over here. So we have 7, and then we have 1, 2, 3. Now, if we're proving a square, right, even if it gets hard to count the boxes, like, you know that your diagonals should be congruent anyway. So if you get your diagonals to not be congruent and it's telling you to prove a square, something's wrong, right? So again, I'm going to rewrite this. 7 squared plus 3 squared equals c squared, and we already did that math. We get radical 58 equals c. And now we just got to finish up our concluding statement. So now we have that property of the rectangle checked off. So now I'm good to go. Right, so now my last sentence should be DEFG is a square because it is a rhombus. And then we're going to say the property that we use for the rectangle, right? So it's a rhombus with congruent diagonals. Now, very tedious, lots of work, but this is a lot of points on your Regents exam, so you want to make sure that you go slow and you get every single point where you can. And again, if Pythagorean theorem gets too tough to see your diagram, then what you need to do is use the distance formula and use exactly what we did for FE to get your answers, okay? Now, this proof was one of the more complex ones because we needed to check off so many things off the checklist to get to square, but square isn't going to be the thing that you're proving all the time. If you're proving a rhombus, the process is going to be a lot shorter because you only need to check off 2 of the things and not all 3. If you're proving a rectangle, again, it's going to be shorter. And if you're proving a parallelogram, it's going to be way, way shorter than what we just did. So just be mindful of that and use your checklist and your coordinate proof guide to help you as you guys work.